In this lesson, we're talking about the surface area of 3D figures, and we're going to start with the area of a regular polygon. A regular polygon is one that has congruent sides and congruent angles. So for example, an equilateral triangle is a regular polygon because all the sides are the same and all the angles are the same. The formula for this is 1/2 AP. The A stands for the apothem. The apothem is the perpendicular distance from the center of the polygon to the midpoint of a side. And we'll talk about that in these shapes. And capital P stands for the perimeter of the polygon. So let's start with our regular triangle. So in our triangle, what we're going to do is we're going to divide our triangle from the center to each vertex. And notice it creates 3 triangles. Here in the middle, it's 360 degrees. So 360 divided by 3 is 120. So each of these angles is 120. The apothem cuts down here and makes this angle 60. And then because that's a 60, this must be a 30, and we can use our special triangles. The pentagon, however, when I divide my pentagon into these triangles coming from the center, you'll notice I have 5 of them. And if you draw them correctly, they should all look the same. 360 divided by 5 tells me that each center angle must be 72, which means this triangle where the apothem cuts through, these are each 36 because it divides that 72 in half. And from there, we're going to use some trigonometry to find our apothem. The regular hexagon. Hexagon is a 6-sided figure. So we know when we create these triangles, 360 divided by 6 is 60. This angle is 60. So the apothem must cut this one in half to be 30. So again, we have our 30, 60, 90, and we can use our special triangles for that. So here's how that works. Find the area of the regular hexagon. So we know that, so in my regular hexagon, we already decided that this triangle right here, remember we did 360 divided by 6, and that told me that this entire angle was 60. So now that's a 30. I'm going to draw this over here just for us to look at. This is 30. Each side length of my hexagon was 12, so that got divided in half. And I need to find my apothem, which turns out is the long leg of the 30, 60, 90. So in this problem, the apothem is 6√3. The perimeter, since one side is 12 and it's a hexagon, 12 times 6 is 72. So I plug those into my formula for 1/2 apothem times perimeter, and I get my answer times 6 times 72. Now you know I want this in radical form, so I'm going to say 260.5 times 6 times 72. Should give me 216√3 square inches. All right, let's look at the pentagon. Find the area of the pentagon. So when I make my triangle for my pentagon, remember a pentagon has 5 sides. 360 divided by 2 tells me that this entire angle is 72, and it just got cut in half. So that's a 36. So we're going to make this a little bit larger just to be easier to look at. There's my apothem that I'm looking for. Now my base, all the sides are 18, so my base got cut into 9 and 9. So we're going to do some trigonometry because this is not a special right triangle. So from here, I would notice that my 9 is opposite, x is adjacent. So I'm going to say tangent 36 equals 9 over x. Grab my calculator. Since x is on the denominator, I'll be dividing by tangent 36. And I get 12.387. I'll just put ... I'm going to grab that number off my calculator in a minute. Now, some of you might have noticed, hey, if that's 36, can I use this angle down here? Well, since 180 minus 36 plus 90 is 54, you could actually use the 54 that's down here. In that case, you would have said tangent 54 equals x over 9. And then 9 times tangent 54 gives you that same 12.3 number. So either way, it works. You can use the 36, just be careful, or you could use the 54. So now I'm ready for my formula. 1/2 Apothem, which was the 12.3. I'm going to use the calculator number. Perimeter, 18 on each side times 5 is 90. So I'll plug that in. 1/2 times the Apothem times 90. I get 557.435 square inches for the area of my regular pentagon. So next up, we need to talk about our lateral and total surface areas. Now I noticed that this little 2 pi r squared was supposed to go at the end here, but it ran out of space. So that surface area formula should have the plus 2 pi r squared on it. Now in these formulas, just a reminder, capital B is the area of the base. Capital P is the perimeter of the base. R is the radius, H is the height, L is the slant height. That's a new one for us. L is the slant height. So here we go. I'll tell you what that means when we get there. The first question is find the lateral and total surface area of this rectangular prism. Get it under the camera. So I shaded the base so that you would know this is a base and this is a base. The lateral area formula says pH, perimeter of the base times the height. Well, if the base is a square that's 4 by 4, the perimeter of the base is 4 plus 4 plus 4 plus 4. The height of the prism is going to be the distance between the bases, because we're talking about the height of the prism. So that's 22. So perimeter times height gives me the lateral area of my prism, 352. The total surface area wants us to do the lateral area plus 2 bases, 352. The lateral area of a prism is just the area of everything except the 2 bases. So lateral area is just the sides, but not the bases. Total surface area includes the bases. So since the base is a square that's 4 by 4, 4 times 4 is 16, and I get my total surface area. When you think of surface area, think about what would it take to paint the entire outside of this shape. And that's going to be your area. Your volume, you're filling the inside of a shape. Surface area, we're just going to paint the outside of the shape. And that's my total surface area for this one. Next is the area of a pyramid. So we're going to determine the lateral and total surface area of the right rectangular pyramid. The base is a rectangle this time. So when we find the perimeter of our base, this is a rectangle. So 5, 5, 3, and 3. My perimeter is 16. The area of my base is easy to find because it's 5 times 3. And here's where we talk about that slant height. The slant height, that L in your formulas, is the height of the slanted triangle. So when you hear slant height, think it's the height of the slanted side. And this one they gave us was 4. So that counts as our slant height. And now we plug numbers into the formula. So for a pyramid, it is 1/2 lateral area is 1/2 PL. Perimeter of the base times the slant height. So P times L. 16 times 4 is 64 square inches. So that was the the area of the triangles all around, but we didn't include the base. So total surface area is going to be this number plus the base. This time there's only one base because it's a pyramid, and the area of the base was 15. So I get 79 square inches for the total surface area of my shape. A cylindrical paint roller has a diameter of 2.5 inches and a length of 10 inches. So you picture a paint roller, something like that. The diameter is 2.5, and then the length is 10 inches. So 10 is going to be my height, and half of 2.5 is going to be my radius. So when you look at your formula for the lateral area and the total area of a cylinder, this one is 2 pi RH, and then the total surface area is this one plus the two bases. And since the bases are circles, that's pi r squared. So the radius of my figure is half of 2.5. The height of my cylinder is going to be the 10. And you just plug the numbers in. So 2 pi radius height. And since we're going to do this in terms of pi, we're going to multiply everything except the pi. 2 times 1.25 times 10. So the answer is 25 pi square inches. For the total surface area, we're going to take the answer we just got for lateral, and we're going to add the two bases, the 2 pi r squared. 2 pi times 1.25 squared. Make sure you use the radius when you do your area there. So 2 times 1.25 squared gives me 3.125 pi plus the 25 pi that I already had. So my answer is 28.125 pi square inches. So that's for a cylinder. This particular shape is a right hexagonal pyramid. The reason we call them right pyramids is because it's opposed to oblique. An oblique pyramid kind of slants to the side. This one is straight up and down, and the height would be perpendicular to the base. All right, the lateral area of a pyramid. So we're going to pull that off of our formulas. 1/2 perimeter times slant height. The total surface area is going to be the lateral plus my base. So I'm going to go ahead and do these calculations so I can just plug the numbers in. The perimeter of the base should be pretty easy. It's a hexagon, and every side is 8 feet. So the perimeter of my base is 48. 6 sides times 8. The slant height I gave you was 14. So the only other thing I need to find is the area of my base. Well, the base is a regular hexagon. So remember that formula was 1/2 apothem times perimeter. So the apothem they gave us was 6. The perimeter we just found was 48. So I do know the area of my base is 144. Now I can just plug numbers into the formulas and get my answers. It's easier if you do this first. So the lateral area, 1/2 perimeter times slant height. And I put that in my calculator. Is 336 square feet. Now I use that number and I add to it the area of my base to get my total surface area. And my base was 144. So I'm going to add 144 and get 480 for my total surface area of the hexagonal pyramid.